For the introduction of the case study, a cafe frequently struggle to efficiently handle their resources while satisfying customer demand. Espresso shots and milk are among the various amounts of components needed for popular drinks, including lattes, cappuccinos, and mochas. A cafe management might be aware of the total quantity of ingredients used at the end of each working day, but they might not be aware of the exact number of cups sold for each beverage. This case study demonstrates how linear algebra can be used to model the cafe's production data as a system of linear equation. Gaussian elimination or Cramer's rules can be used to quickly and precisely calculate the quantity of lattes, cappuccinos, and mochas sold.
Now, I want to talk about purpose of study. I want to explain why we can use algebra in cafe drink production. So, our first objective is to determine the exact number of lattes, cappuccinos, mocha, and americanos sold in a single day. We are doing this by analyzing the cafe's daily ingredient usage data, working backward from inventory consumption to precise sales figures. Next, our second goal is to apply Gaussian elimination to a real-world business settings. Cafe operation involve multiple variables like espresso shots, milk, sugar, and cups. By structuring this inventory constraints into a system of linear equation, we can use this algebraic method to solve the daily sales puzzle. Lastly, our third objective we want to demonstrate just how crucial linear algebra is to everyday business decisions. The study shows that it isn't just an abstract theory, it is a practical tool that helps cafe managers monitor their resources efficiently, eliminate waste, and make smarter data-driven operational choices.
Problem statement. A cafe sells 4 types of beverage. That's it, latte, cappuccino, mocha, and americano. Each drink requires different amount of espresso shot, milk, sugar, and cups. At the end of the day, the cafe recorded that 250 espresso shot, 390 units of milk, 310 units of sugar, and 180 cups were used. However, the cafe manager does not know the exact number of each drink sold. Therefore, a mathematical approach is needed to determine the quantity of latte, cappuccino, mocha, and americano sold based on the available resource usage data. This problem can be modeled as a system linear equation and solved using the Gaussian elimination method. Analysis of problem. Latte were used 1 espresso shot, 3 ml milk, 2 gram sugar, and 1 cup. Cappuccino used 1 espresso shot, 2 ml milk, 1 gram sugar, and 1 cup. Then mocha used 2 espresso shot, 3 ml milk, 3 gram sugar, and 1 cup. And then americano used 2 espresso shot, 0 milk, 1 gram sugar, and 1 cup.
Now we go to methodology. Looking at step 1, we define our 4 unknown variables representing the drink sold. We set X equal to latte, Y equal to cappuccino, Z equal to mocha, and W equal to americano. In step 2, we construct our system of 4 linear equations based on the cafe's data. Our first equation is X plus Y plus 2Z plus 2W equals to 250. The second equation is 3x plus 2y plus 3z equals to 390. The third equation is 2x plus y plus 3z plus w equals to 310. And our fourth equation is simply x plus y plus z plus w equals to 180. Finally, in step 3, we translate the system into a 4x5 augmented matrix by prepare for row operation. The first row is 1122 augmented by 250. The second row is 3230 augmented by 390. The third row is 2131 augmented by 310. And the fourth row is 1111 augmented by 180. This set up our data completely for the Gaussian elimination process. In step 4, we solve our system using Gaussian elimination to create an upper triangular matrix. We start with our initial augmented matrix. Our first goal is to eliminate the leading coefficient in the first column below the first row. To eliminate the 3 in row 2, we apply the row operation. Row 2 minus 3 times row 1 becomes the new row 2. This change row 2 to 0, negative 1, negative 3, negative 6, augmented by negative 360. Next, to eliminate the 2 in row 3, we apply row 3 minus 2 times row 1 becomes the new row 3. This updates row 3 to 0, negative 1, negative 1, negative 3, augmented by negative 190. Following that, to eliminate the 1 in row 4, we calculate row 4 minus row 1 becomes the new row 4. Row 4 now becomes 0, 0, negative 1, negative 1, augmented by negative 70. With the first column clear below the pivot, we focus on the second column. To make calculation easier, we want a positive 1 as our pivot in row 2. We apply the operation negative 1 times row 2 become the new row 2. This change all sign in the second row, leaving us with 0136 augmented by a positive 360. This sets us up perfectly for the remaining row reduction to solve for our dream totals. Continuing our Gaussian elimination on this slide, we perform the operation row 3 plus row 2, which become the new row 3. This eliminates the negative 1 in the second column of row 3, resulting in a new row 3 of 0023 augmented by 170. Row 4 remains 0, 0, negative 1, negative 1 augmented by negative 70. Next, to make our calculation cleaner, we swap row 3 and row 4. After this, interchange our third row becomes 0, 0, negative 1, negative 1 augmented by negative 70. Our fourth row is now 0, 0, 2, 3 augmented by 170. To create a positive 1 as our leading pivot in the third row, we multiply row 3 by negative 1. This changes the signs across the entire row, giving us 0, 0, 1, 1 augmented by positive 70. Finally, we eliminate the 2 in the fourth row using our new pivot. We apply the row operation row 4 minus row times row 4 minus 2 times row 3. This reduces our final row to 0, 0, 1 augmented by 30. We have now successfully achieved an upper triangular matrix, completely set up the system for back substitution to find our final average counts. Moving on to step 5, we extract our equation from the upper triangular matrix to solve for x, y, z and w using back substitution. Equation 1 is x plus y plus 2z plus 2w equals to 250. Equation 2 is y plus 3z plus 6w equals to 360. Equation 3 is z plus w equals to 70. And from the final row, equation 4 directly gives us our first solution, which is w equals to 30. Back substitution for z and y. Next, we substitute w equals to 30 into equation 3, giving us z plus 30 equals to 120. Solving for z, we get z equals to 40. Now, we substitute both z equals to 40 and w equals to 30 into equation 2. This set up the equation as y plus 3 multiplied by 40 plus 6 multiplied by 30 equals to 360, which is giving us the y value equals to 60. Finally, we substitute all three known value, y equal to 60, z equals to 40 and w equals to 30 into equation 1. This gives us s plus 60 plus 2 multiplied by 40 plus 2 multiplied by 30 equals to 250, which is giving us s equal to 50. To summarize our final breakdown of coefficients for the day, latte soul equals to 50, cappuccino equals to 60, mocha equals to 40 and americano equals
Based on the result obtained, The most popular coffee sold is cappuccino with 60 cup, and the floor is latte 50 cup and mocha 50 cup. And the least the coffee sold is americano with 30 cup. Discussion. From the discussion, we can see the cappuccino emerge as the best performing product with the highest sale as the 60 cup, while americano were the lowest perform at 30 cup. By analyzing total ingredient usage, this method successfully uncovered the exact number of cups sold for each beverage critical operational data that was previously unknown to the manager. Then, utilizing linear algebra replace subjective guesswork with purchase quantitative analysis. This empower manager to optimize resource management, reduce waste, and make data-driven business decision. This analytic framework is fully replicable and scalable. It can easily expand to track additional drink type or different ingredient without adding unnecessary complexity to the decision-making process.
Now it's about conclusions. This case study shows that by using system of linear equation can be solved using the Gaussian elimination method. The cafe can determine how much espresso shots, milk, sugar, and cups has been used in just one whole day. By using elementary row operations, we had succeeded on reducing into row equivalent form and revealed a consistent system with a unique solution. This shows that by applying linear algebra for a storage or amount of used ingredients, problem can be solved for the future problem using the same method.